Okay, so we're on lesson 130. The topic of that chapter is services, building services. But one small part of this chapter is the cost of electricity usage, and that's what I want to cover here. So there's a lot of info in this chapter. A lot of it is just kind of factual. You read it, commit it to memory, understand it. There's not a lot of kind of math and calculations here. I do want you to spend a lot of time sort of get your nose in the textbook and get into the text, because there's a lot of really useful, important information about services. But I'm going to do something a little different, and we'll pull this kind of smaller piece of the chapter out, and that's the cost of electricity usage. It's kind of one of the only real sort of math-based or technical-based things here. But it's something that kind of goes over a lot of people's heads for some reason, and I think there's just maybe some unfamiliar terms. Not a lot of difficult math. It's just a matter of understanding where and how to use it. But what I'm going to actually look at here, and it's something that's become very popular with the advent of LED lighting, is let's look at the cost of operating this 400 watt metal halide versus this 136 watt LED, which should be a direct replacement as far as light output goes. What kind of energy savings, and more importantly to the building owners, money savings are you going to see here? What should you expect? So we've got to understand a couple of things before we do that. So first of all, we're charged a price per kilowatt hour for electricity usage. So what is that? Well, we already know we can measure how many watts something uses, or kilowatts as it would go. So for how many hours are we using that many kilowatts? It's quite literally kilowatts times hours equals kilowatt hours, right? So you have kilowatts, and mathematically, if two variables are up against each other with no symbol in between, kilowatts times hours, it's multiplication. So for how many kilowatt hours, we have a price per kilowatt hour. For this example, we're going to use 14 cents per kilowatt hour. That's probably pretty common, depends where you're at, things like that. So for every 1 kilowatt hour we use, we're going to be charged 14 cents from the power company. And in this, let's say we're in some kind of a factory facility. Let's say they're operating for about 12 hours per day. If you do the math at a 52-week year, 5 days a week, let's say it's 268 operating days. So these guys are going to have these lights on for 3,120 hours per year in this example, okay? And let's say they have 30 of these fixtures. They want to replace 30 of these fixtures. What kind of cost savings might I expect to change from our metal halide 400 watt to our 136 watt LED? So let's jump in here. First of all, this is rated in watts. Our calculation is for kilowatts, so we got to make that change. We should be able to do that easily, because that was kind of beginning of the year stuff. 400 watts divided by 1,000, or move that decimal point 3 places to the left to go from watts to kilowatts, we get 0.4 kilowatts, right? Then we have our 0.4 kilowatts times 3,120 hours. Why are we doing that? Kilowatt hours. Kilowatts times hours, right? So 0.4 kilowatts times 3,120 hours gives us 1,248 kilowatt hours we are going to use by operating these lights for one full year, 260 days, 12 hours a day. So now we know how many kilowatt hours we expect in a year. We already said our 14 cents, so we're just going to simply multiply the two. One of these fixtures we should expect to cost about $174.72 per year to operate. Again, we have 30 of these things running at any given time. So over the course of a year, for 30 lights, we're expecting $5,241.60 to operate these 30 lights. Okay, so for the sake of repetition and to solve our problem, let's go ahead and solve it for the LED light as well. Again, we have watts. We need to take that to kilowatts first, so we can divide by 1,000, or move that decimal 3 places to the left. 1, 2, 3 would give you 0.136 kilowatts. So significantly less, right, already. So here we say 0.136 kilowatts times 3,120 hours. Once again, kilowatt hours is kilowatts times hours. So 0.136 kilowatts times 3,120 hours gives us 424.32 kilowatt hours. Again, significantly less already. So now we'll take that kilowatt hours, 424, times our 14 cent rate, and we'll get $59.41 will cost to operate one of these fixtures for our full year, 260 days a year, 12 hours a day. Again, that's looking pretty good for our LED light here. So the last step, what if we operate all 30 of them? We take our $59 times 30, $1,782.30. That's a pretty big savings for just 30 lights. So, take that the full way. In 1 year, the facility would expect to see $3,459.30 of savings per year on operating costs alone. And there's other factors that can weigh in here. Maintenance costs. We don't have to replace lamps as often, theoretically, in LEDs. But this is a very real calculation that many electricians, especially if you get into estimating sales or anything like that, that type of calculation is something you're going to find yourself doing quite often, and more as LEDs are more feasible. These facility owners want to see what does it take to change these out, and then they're going to weigh that against the cost of the project, right? Because we're going to charge a certain amount of money to provide the lights, install the lights, and they're going to look and say, well, how much can I save per year? What's the payback period? If it costs them $7,000 to install these lights, just to pull a number out of the air, they can say, oh wow, in almost 2 years I can have this cost of this project recouped in energy savings. So it's kind of a little edge you can get on your salesmanship anyway. But like I said, that's sort of a quick review of how we calculate energy usage costs, and also compare LED savings as well. But anyway, there's a lot more in this chapter, a ton of stuff. Again, it's just a lot of reading, facts, things to sort of commit to memory and understanding. But take some time, read through all these, because there's a lot of good stuff in there.